much as possible. Okay, so graphing, my first idea was transformations. That's what kind of idea that was. So we're going to identify these as a transformation letter, A, B, C, D. That's what we're going to do. So we have an A in the front, this would be a C, and this is a D. So what kind of math are we going to do to these coordinates? X plus 3, 2y minus 1. Nailed it. Okay. Anything x related, you do opposite. So if it says something times x, you actually divide. If it says minus 3 with the x, you actually add, right? So now what you do is you take some coordinates. So let's go here. This one is negative 3, 1. This one is 0, 1. So I'm taking this coordinate. I'll grab this little bottom coordinate, 2, negative 2. And I'm going to grab the last one, which is 3, 0. Okay, they all have to go through. So for speed, just do all the x's. So add 3, add 3, add 3, add 3. Okay, now I go through all the y's. 2 times 1, 2, subtract 1. Negative 2 times 2. Now we're at negative 4, subtract 1. 0 times 2, subtract 1. Okay, make sure you connect your dots properly. That's where I notice people get mistakes on their exam, is the connections. Also understanding, should there be arrows or not arrows? Make sure you understand that. Okay, so does your thing make sense? So this vertical stretch of 2, how much vertical space is there on the original? These are 3 apart. That's how much vertical space is happening. How much vertical space is on this shape? How far apart are they? There's 6 vertical spaces. You see it? That vertical space got doubled. Okay, and then can you visually see that there's a shift right 3 and down as well? Can you see all those things kind of happening? Okay, ABCD stuff. Please make sure you have this. It applies to so many things. Make sure you know what you're doing here. Right? That's the foundation of a lot of things. That little thing right there, right? Okay, we're going to determine an equation for g of x based off of f of x. So g of x is going to be f of x with stuff happening to it. g of x was us doing stuff to the f function. So we have to start with f, and we have to end up with the g. Okay, so here's my question. You have to visually see what kinds of things did we do to f. Okay, please answer first. Have we done any compressions or stretches or reflections? Because those are our multiply, divide stuff. Can you see anything that you've done? Have you stretched it, anything, compressed it, reflected it? Horizontal compression. Okay, can you, let's say, go from this point to the tip point, and then this point to the tip point? Can you see how much space there is? From there to there, how much space? 1, 2, 3, 4, 5, 6 spaces. Now there are 3. So I have horizontal compress by 2. Okay, so I'm going to visually do that. Okay, so what does it mean? It means x values need to be cut in half. So this coordinate was at a -2. Now it would be at a -1. This coordinate, x value 0, would stay at 0. 1, 2, 3, 4. The bottom of the V is at 4. So if I compress it, it would go to 2. So I'm going to kind of take another coordinate here. I'm going to make one. 6, 2 would now go to 3, 2. Okay. Now I would like you to put your eyes onto this graph after we've compressed it. Is there anything else we have to do to it? We would have to move it up. 1, 2, 3 up. And then we're done, right? We've matched it. So if we squish it in and then move it up, it will land there. Order of operations though, right? Reflections, compressions, stretches have to happen before shifts. The next question asks us to do inverse. So a couple things about inverse. What's another way of me saying graph the inverse? Here's another thing I could have done to ask the same question. So understand the symbol for inverse, right? It's really easy to remember this symbol because you guys know where your sine inverse button is on your calculator, right? It has that little -1 in the top. That means sine inverse. This means function inverse. Another way to ask it is reflect over y equals x. That diagonal reflection also. Okay, but the most important thing is, well, this is understanding the question. What do you do with inverses? Every coordinate would happen to do what to it? Coordinate switch, right? Inversing, that's what you do. Okay, so here we go. 1, 2, 3. So negative 3. This coordinate is negative 3, 2. So I'm going to go to 2, negative 3. So that's what I'm doing. Negative 3, 2 becomes 2, negative 3. Negative 1, comma 4. Okay, now, one exam, I had a kid aiming for 100%, and they got 98 because they forgot to connect properly. They had all their points correct. How do we connect the dots? There has to be an arrow. Which way is your arrow going? So do we do it properly? Okay, I'm gonna draw the imaginary diagonal. That's that imaginary diagonal. Y equals x, that's the imaginary. Does it reflect? Do you see it? That diagonal reflection. Okay. We had what I call invariant on this. Where did we have an invariant point? 2, 2. So what causes invariant on inverses? If x and y are the same number, when they switch, they don't change, right? So 2, 2 was invariant. You can see it. Okay. The next was the reciprocal function. So here's the word, here's the symbol for understanding reciprocal. So we reciprocate something, we flip it. So there's kind of a few ideas. We only flip heights, right? F of x means heights. So we're flipping heights. So the first height I deal with is 0. What happens when you flip 0? What would you call this value? Undefined. How would you graph the number undefined? Asymptote. An asymptote? Okay, so where do you see a height of 0? At the coordinate 1, 0. So 1, comma, undefined. If I ever asked a question that just said, what's the equation of the asymptote? What would this equation be if you had to write it? X equals 1. Okay, now the next thing I do is 1 and negative 1. Why do I pick those values? What's special? When you flip 1, they just stay, right? Invariant. When you flip 1, it's 1. So actually, you know what? That's this whole flat section there. It stays there. And there. And the last idea I do is away or close, close away. So remember, if you had 100, that's really far away. You move it to 1 over 100, which is really close. Okay, so what's going on with the heights of the graph right now where my pen is in this section? These are really close values to 0, small. So I'm going to go big. I'm going to move away. And this region, Same thing, I'm going to go away. Don't touch an asymptote. Don't curl away from an asymptote. Okay, I do not have an asymptote here. What would the case be where I would have to add a horizontal asymptote? If your original graph had an arrow like that, that would add a horizontal asymptote. Because if your original graph is doing this, it would be heading away from 0 forever. So if the original headed away from 0, your reciprocal graph would head towards 0. Never touch it. That's asymptote behavior. Okay, so that would be another scenario that could happen. Okay, this one is called absolute value. So what do we know about absolute value? What happens if you were to absolute value a positive value? It would stay. What about if you absoluted the value 0? It would stay. What happens if you absolute value a negative value? It would have to change. Because it's a distance, right? That's the only thing. You can't have that negative. Okay, now here's my question for you. I see an absolute value and I see a down 1. What should I do first? I should absolute it, then I should move it down. Okay? If this was inside that bracket, then it changes that order. Okay, so I am going to draw a light sketch of just absoluting it, and then we'll move it down. Okay, so here's my absolute value. Actually, I'm going to draw it yellow. I'm going to go yellow. Okay, so I'm going to do this. I'm going to keep, right? Do you see why I'm keeping that section? It's all 0 or positive. So that's what I did. I kept that section and I made this little negative section, I've changed it. Okay, now this is my yellow graph. I'm going to now shift that yellow graph down 1. Okay, so the orange graph that I drew there, that's my final graph. Okay, so does that make sense? Make sure you do the order. When I do absolutes, I actually draw and then draw. Okay, radicals. Okay, when you do radicals, your domain and your range are always restricted because, right, we can't square root negative values. So your domains will always be either a number to infinity or negative infinity to a number. It's always a restriction like that, by the way. That's something to know about radicals. Okay? Radical shape is like that, right? Radical shape. We can reflect it, though, so that's why it could change. Okay, so that's a good understanding. What's the pattern of this thing? Do you remember how to make patterns? 1, 1, 4, 2, 9, 3, right? Opposite of squared. Okay, question 6 here came from a multiple choice on your exam. Where do you see multiple choice on your exam? You always will see it when you first open your second booklet. Okay, there's about 8 or 9 questions that are multiple choice. You do not have your calculator as soon as you get your second booklet. So you for sure don't have a calculator for this question. When you do your multiple choice on your exam, you're going to get a bubble sheet for that. Okay, so I'm going to remind you, but you'll have to have a pencil, a number 2 pencil with you, because you will have to do 8 or 9 bubbles on your exam. Okay, what does the word x-intercept mean? No matter what you're dealing with. Y is 0. Okay, what do I do to solve this? I'm going to square what do you want me to do? I could do 2 things here. I could just divide by 2, or I could FOIL and then move. It doesn't matter. I'm going to go divide by 2. Yes, but like if there had been a number here as well, like you'd have to do some more algebra then. Does that make sense? You know what I mean? If I had like a plus something. Yeah, then I'd have to move it and then square it and then, or whatever. Yeah. But yes, on this question, what you're saying would work, but. Okay, graphing radicals. You have 2 things you got to do. You have to say, where does this thing start and how does it move? Those are your 2 questions with radicals. Okay, so where did we start? When you start, we look for, did we move anything C or D? We have a C, no D. So all we've done is left 5. So that's where I'm going to start. And here's my movement, 1, 1, 4, 2, 9, 3. Is there anything that's going to change my movement? Now I'm looking for A's and B's. This is a B. What do you do with B values? Divide X. So I have to divide over, the over side, by 2. So a half, a 2, and a 4.5. Okay? So that's it. That's all you need to understand with graphing radicals. Where do you start? How do you move? Okay, state the range and domain of this radical. So here's my first question. Where should we start this radical? What's the coordinate? Positive 8, positive 1. Opposite for the x stuff, right? And this is normal. That's normal. We're not normal though. Why? There's a negative which causes a reflection. So this is a reflection. So which way do we reflect? We have to change the heights, negate the heights. Okay, so that's it. That's what's happening. We knew the start point and we figured out the direction. So there we go. Now we need to write. So domain, I'm heading from 8 to the right. And range, I'm coming from the bottom up to 1. Okay, and this one is very similar, except for I gave it to you backwards. Okay, this time, here's my starter. -2 and 3, that's my start coordinate. Okay, my domain says less than, so I'm heading, that makes me head in a left direction. Y is greater than something, so that makes me head upward. So what does your radical shape look like? That's what I know. I know it's starting there, and I know it's heading like that. So, is that normal? No, I just did a normal one there. So this is a negative B reflection. Okay, so I need to write an equation. So how am I going to do that? What should I start this thing with? F of x equals or y equals, because it did not specify, so that's fine. Y equals square root negate x plus 2 and a plus 3. And here's where like 25% of you lost marks on your test. The B is always factored out, right? Okay, rational means fractions. So how do I start? I, first and foremost, with fractions, this is always like your number one thing you're always analyzing, is with fractions you don't ever want to divide by 0. Right? We don't like dividing by 0 when we work with fractions. So, what am I going to do? We're going to start by factoring the bottom. X minus 4, x plus 1. Okay, so these are called NPVs, non-permitted values, 4 and negative 1. What do we know about the non-permissible value rule? It's going to be a vertical asymptote unless there was a canceled factor, then it is a whole. Okay, after you cancel this, your equation looks like that. After you've canceled, you now have 1 over x plus 1. So can you get me the coordinate of the whole? 4, comma. You're plugging it into here. 4, comma. Did you get 1/5? Because I put the 4 into that spot. Okay, great, we're done that work. Okay, now we got to do the degree work. What do you think? Are we same, higher, somewhere? We had higher degree on the bottom. So what do I know about my number value? It's getting, if you have a higher bottom, you get smaller and smaller and smaller. This is called a horizontal asymptote. If the degrees are the same, you divide coefficients and you're going to have a horizontal asymptote somewhere. If the degree is higher on the top, nothing. Okay, so there's my 3 things: vertical asymptote, horizontal asymptote, whole. Okay, now I'm going to get just random coordinates so that I can make a shape. So when I pick x values, I usually say I'm going to just grab a few on this side. So I'm going to take 0 and 1. And then I'm going to go over to this side and I'm going to take a -2 and a -3. Okay, good with remembering rules. Non-permissible values, vertical asymptotes or holes. Degree analysis, higher, same. Okay, these next two questions have us graphing logs and exponentials. So it doesn't matter if it's a log or an exponential. Your first question is, what is the base? Always. What's your first question? What's the base? What's the base of this? 5. Then you run 5 to the negative 1, 5 to the 0, 5 to the 1. Okay, because this is a log, how should I write my coordinates with logs? Results, comma, exponent. Results, comma, exponent. Okay, so when you do logs, it's that inverse situation, right? Results, comma, exponent. Okay, that's it, and then you apply transformation stuff. So do we have any ABCDs going on? We have a C, so we are going to have to apply that. And that's it to these coordinates. And what do we know about log graphs? They have to have a vertical asymptote, and we should put that asymptote at 1. What do you know about the result of a log? Always has to be positive. Remember that? Results always have to be positive. To stay positive, what do you have to be? Above 1. So, can I touch this asymptote at 1? No. I have to be on this side of it. Logs always have vertical asymptotes. Okay, this is exponential, so I'm going to do the same thing. What's the base? The base is 2. The base is not negative 2. Do you see that? What would the difference be? This has a base of negative 2, but this has just a base of 2. Okay, do the same thing. 2 to the negative 1, 2 to the 0, 2 to the 1. Okay, this equation is exponential, so how should I write my coordinate? Exponent, comma, results. I'll call that your normal brain pattern. Logs is what makes you think backwards, right? Input, output. Now, transformation language. A, B, C, D. A and a D. Okay, do you want to know what a B would look like? That would be a B, right? Because it's with the X part of it. Okay, so we're going to go nothing to X values. And we're going to negate Y and add 2. Okay, negative a half plus 2 is now 1.5. Negative 1 plus 2. Negative 2 plus 2. And what should exponential graphs always have in them? A horizontal asymptote. They have to have horizontal asymptotes. Okay, logs, verticals. If you have no idea what's going on still, what could you do? Just do more points, right? You always have that skill. If you don't understand what's going on in a graph, just keep inputting, outputting. You can make more points if you don't understand what the pattern is doing. Right? On the exam, you always have that tool. Okay, what do you know about this? If the base is 2, what happens to something with a base of 2? It will grow. If the base is bigger than 1, it grows. And what happens when the base is less than 1? It decreases. Okay, that actually matches, doesn't it? So D would be a reflection of this one. So this would end up going like that way, reflecting. And this would reflect that horizontally. Okay, let's see if we can do the last question here. Okay, I'm going to apply A and B. And cos. I'm going to do A, B, and I'm going to do cos. Okay, what does cos look like, or how does it start? Cos starts on a top. Okay, that's a cos curve. It starts on a top. Sine starts where? In the middle, but going upward. Okay, so this is a cos. This is a height of 1 and negative 1 until I stretched it. So now that's 10 and negative 10. What is this x value supposed to be originally? 2 pi. What should I do with x values? Divide by b. X values get divided by b. Flip, multiply. Now this is a 4. 2 pi, divide by b. Oh, this is nice math. What is the tick mark here, 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 here now? 1, 2, 3, 4. That makes it nice. Okay, now I got one more thing now. I have to do C's or D's, and I have a C. What should I do with that C? I need to move right 2. So I'm going to take my original 0, 10. I'm now going to put it at 2, 10. And I'm going to follow the pattern. I'm on a top. So when I hit the next tick at 3, I should be on a middle. Continue the pattern from the middle. Now I head to a bottom. I'm going to go to 5. At 5, I'm middle. I'm going to go to 6, top. I'm going to stop at 6. Why am I stopping at 6? Because the question told me to stop at 6. And what's my problem still? I have to go to 0, so I have to backtrack. So at 1, what's the pattern? Middle, bottom. Otherwise, you would have arrows, but it told me not to.